Okay, everyone, so we are going to look now at what the book says about multiplication and division. So this is going to be kind of a silent blank screen for you for a little while, so get your books out and let's take a look at chapter 10. And we had looked at the addition and subtraction fact strategies last time. So this time I want to go to reasoning strategies for multiplication and division. In the current edition, it's on page 181. But just so you see what they have here. So they talk about kids learning their doubles. That's one of the easiest things to do. So doubles are multiples of 2. That's not difficult. Clock facts. The fact that they have to be able to read an analog clock and have to skip count by fives to get the minutes. So that's something that already happens in second or third grade, or maybe even before. And typically you'll have classroom toy clocks that may not actually tick, but where the hands move. If you have a choice in the matter, it would be nice to have the kind where if you move the minute hand, the hour hand moves with it. Instead of you know how it is when you go from 1 to 1:30? The little hand goes between 1 and 2. It doesn't stay at 1. And sometimes that's confusing for kids. So it's important that you do that movement carefully. Okay, and then on the next page, they talk about nifty nines. And this has kind of got to do with the dividing by nines, but thinking about using tens to think of the nines. The nines are 1 less than a 10. So think about this. If you were to have to do 9 times 6, could you do 10 times 6 quite easily? They can usually do that. But then the idea is to subtract that 1 times 6. So this is having level 3 understanding is what this takes. Does that make sense? They have to be able to decompose a number to make sense of that. If they're still counting on their fingers, that doesn't work. So this is why by third grade they need, if you're a first or second grade teacher, you need to make sure you're sending your kids forward with level 3 ability on adding and subtracting. Okay? That's why I had you do that assessment. Just keep that assessment in mind. It tells you wonders about why a kid is struggling with things. Okay, so you can look at the rest of the book to see other activities, but what I want to look at is some particular ways to work on multiplication facts. One thing is there are different representations we can use, and one of them is same number groupings. Okay, so say we roll 2 dice, and the one number comes up a 4, and the other number comes up a 3. Okay, so what we have then is 4 groups of 3. So it's important to have it written down. Okay, but what does that look like in a picture? It might look like this. 1, 2, and remember my 3s. I'm kind of picky about this. Oh dear, what have I done here? 1 group of 3, 2 groups of 3, and it looks like a funny face there. And my 4th group of 3 will be grouped separately. So that's the same as 3 plus 3 plus 3 plus 3, which is 12. Okay. The other method that we can use with this is a row of 3, 4 rows with 3 in each row. And this is the array representation. So 4 rows, 3 in each. So this is quite important because this is the area model. And if we do enough of this area model, then later on they won't have trouble with it in measurement. Does this make sense?
You're missing one more row.
Oh, I'm missing one more row. Thank you. Keep me on my toes. So the language is, how many rows do we have? 4 rows. How many are in each? 3. How many is that? And this representation lends itself to kind of dividing it into 2 rows of 3, which is usually easy. Twice. Do you see that? So that's one of the things. I watch my 3rd grade teacher, and she has the kids drawing these things on grid paper, and then even cutting them to separate the 4 rows into 2 rows. So, just so that they can work with easier numbers and see that breaking them apart and putting them together again amounts to the same thing. That really leads to the thinking behind the distributive property, believe it or not. So it's pretty important. Okay, and the other one is the number line. So 4 groups of 3, if we can jump 3 units 4 times, so if we start at the beginning here, which is not 1, it's really a 0. Okay, so think about a ruler or a tape measure. If the frog on the number line jumps, can I draw a little froggy? I don't know if I can. He's trying to jump. Okay. So he jumps to 3, then he jumps to 6, then he jumps to 9, and then he jumps to 12. So that's 4 jumps of 3. Does that make sense? Okay. So I'm going to show you how you can do some foldable things with the same kind of activities. And this part will not be recorded, so you'll have to get the picture of this from your peers. So we've been talking about the different kinds of representations that kids need to get lots and lots of practice with. Some of this could feasibly begin in 2nd grade with small numbers. But this is really the thrust of 3rd grade. They're supposed to not only master multiplication, but they also have to get up to a point where they can do 2-digit by 1-digit multiplication. And that's quite a challenge. If kids are not operating at level 3, you can't send them on with any good conscience to the next grade, because the teacher's going to give them multiplication drills to do. And don't fall for that. If you end up teaching 4th or 5th or 6th grade, and you have to teach math, and you find you've got kids who don't know their multiplication facts, it's a real waste of time to just give them drill sheets. Rote practice isn't going to help them get there. So what I'm going to give you now is not in the book. The things in the book will be helpful, but you've got to get them up to speed very quickly. So I want to give you a couple of other strategies that I think would be very, very helpful. So one of them is something a colleague of mine shared with me. Most kids, even if by 2s and 5s, okay? So this is something you might get them to do, and they can always do this on the test, which is really great. So have them write down in a line all their 2's facts. So just like this, and go ahead and make note of this, because this is really good. So the 5th grade child I was helping that summer didn't know her multiplication facts, and I gave this to her. And actually I don't have room on this tablet to go all the way, but I do go all the way up to 30, just to show that you can do big numbers. I haven't messed up, right? Okay, now I know my 5s. 5s are pretty easy, so I'm going to line up my 5s exactly under the 2's. So you could feasibly do this along the margin of lined paper so that they don't go all over the place, especially if they're messy. But it would look like this. 5, 10, 15, 20, 25, okay? And here's the magic. Just for emphasis, I'm going to change color. I know how to add, even if I'm using my fingers. even if I'm a level 2. I can do 5 plus 2 is 7. I can do 10 plus 4 is 14. I can do 15 plus 6. I can do 20 plus 8. So what am I getting? I'm getting my 7s. This is amazing, okay? Okay, so think about this being kind of down the margin, and these being the lines on the paper turned sideways. When they take the test, any test, the STAR test, they can write on the test. They can do this and have it handy. What drives kids crazy is giving them an entire 10 by 10 or 12 by 12 multiplication chart to fill out. And they don't have to. So research has shown that many, many kids know their lower, the smaller numbers up to 5 times 5. The minute you move into the 6 through 9, even 3 times 6 or 3 times 9, they begin to get lost. So this is a way to do it. So my question is, what if so they know their 2s and their 5s, they can get their 7s. How could they get their 3s?
2 and 1.
So 1s and 2s, they could line up 1s and 2s. How could they get 4s? They could just look at their 2s and double them, right? How would they get 6s?
3
They could double their 3s, they could add the 4s and the 2s together. Do you see that there are many ways they could use this? But the point that really comes out of this is even more that it's not a clever number trick without good math, because this is all about if I know how many, if I need to get 27 7s, I could do 20 7s and I could do 7 7s. It's that idea. If I have to do 27 ABs, I could do, it's the undistributive property, if you like. It'll help their algebraic reasoning when they get